In this section of Chapter 11, we're once again going to review those reactions of our epoxides. Remember, our epoxide is the three-membered ring that has the oxygen as one of the members of our ring. We're specifically going to be focusing in on the neutral and the base ring opening of these epoxides. So remember, this is an SN2 type mechanism, and we're always going to see an attack of our nucleophile at the less substituted carbon atom. So if we look at our reaction, we would have our epoxide, and I'm going to show an asymmetric epoxide so that we can look at the attack to that less substituted side. So under our basic conditions, we would have an O-, so an alkoxide anion, typically then also under the alcohol conditions. And we will see that we will add our nucleophile, the OR, to the less substituted side of our epoxide ring, which will put the alcohol on the more substituted side of our ring. We would see something very similar with our neutral nucleophiles, so something like sodium chloride, where we have that chloride ion behaving as our nucleophile. We would have the chloride ion once again go to the less substituted side, and the alcohol would be on the more substituted side. If we look at this mechanistically, we would have our epoxide. We would have that alkoxide anion coming in. It will attack the less substituted side of our epoxide ring. Again, SN2 type mechanism, so it's going to go to the more spatially open side of our ring, and then it will break the bond that we have between the carbon and the oxygen of the epoxide. So this is what causes the initial ring opening. But after that initial ring opening, we do have still an alkoxide anion, so we have that O-, and it is on the more substituted side. So from here, we will have to protonate it, and we will typically protonate it through the use of that alcohol that is also in solution to get us to our final product. That has the nucleophile, the OR, attached to the ring, and we have the alcohol. And again, the alcohol will be on the more substituted side, and the OR, the nucleophile that we added, would be on the less substituted side. Through this process, we have also generated more of the alkoxide anion that we can go on to use in further reactions. The neutral reaction will occur in a very similar process. One of the ways that we can use this, though, is we can use different nucleophiles to extend our carbon chain as well. So we can use our organolithiums or our Grignard reagents, or the cyanide, or the terminal alkyne that we have used previously to help make new carbon-carbon bonds through the use of the epoxide as well. We will need to follow these up with an acidic workup in order to make sure that we get to that neutral alcohol at the end. So these will be two-step processes. So what we need to do with these is once we have that once we have the epoxide, if we're going to add in our Grignard, and any of them would work in the same process, but we'll show the example with our Grignard. Remember, the alkylithium and those Grignards, we're going to treat those as R- species, so the R becomes our nucleophile. That R will add once again to the less substituted side, and when we initially open up that ring, we open it up with the alkoxide anion. We would then have to follow this up with some sort of an acid workup, so we'd have to put it in the presence of an acid so that we can get to that neutral alcohol at the end. So these will typically occur in two-step processes instead of just a one-step process. So if we were to write out the full reaction, you would see that two-step process on our arrow. To get us to the final alcohol. But again, it will be an SN2 mechanism that we would be looking at, so we would attack the less substituted side. We can use a hydride to stop the addition to this chain. So once again, we could also do this process with that hydride, and the hydride will behave as a nucleophile and add to the less substituted side. And this would stop the addition of our chain, but we would still open the ring. Please remember that under acidic conditions from our last chapter, our nucleophile adds to the more substituted side when we are under our acidic conditions. So this is some regiochemistry that you will want to pay attention to.